Here are the answers to the area under a graph 3-question quiz. Your quiz could have gone out of order, so don't worry about question 1, 2, and 3. Just you got these questions at some point. So the first question I'll go over, determining the area under an object's acceleration versus time graph for a fixed time interval will calculate. So basically we're saying, let's say this is A and this is T. T's in seconds. And A is in meters per second squared. Okay, and so if it's something like that, actually, let's just call it something like this. So we're calculating this area. Okay, so we know that the height is in meters per second squared, and then the bottom, the base, is in seconds, okay, which cancels out to meters per second. So it's definitely velocity, right? But you just have to decide which one makes the most sense. So it's either change in velocity, the velocity at the end, the velocity midway through the time interval, or the average velocity. Area under a curve is always going to give us change in something. So this is A, the change during the time interval. The next one, the circus clown that moves on a unicycle in a straight line. The motion is shown in the graph below. You need to see that this motion is velocity time. After 12 seconds, how far is the clown from her original starting point? So area under the graph, that was the name of the quiz, so you figured it out. But anyway, so velocity is meters per second, right? Multiplied, because area is, we're multiplying the height and the width times seconds. So this is so we're just confirming, okay, area under velocity time gives us position, gives us displacement. Okay, so here's what I did. This is a multiple choice question. So I don't really need to know exactly how far it is. I just need to have an estimate. And so I know that the area of this guy is going to be equal to the displacement. Here's the deal. I don't want to calculate that. I would have to break it up. So what I'm going to do is I'm going to figure out each square. Okay, so like this square up here, that has an area of 2 seconds times 2 meters per second. So that has an area of 4 meters. Each full box has an area of 4 meters. So if I count how many full boxes we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 13 full boxes. And then I have, partial boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9 partials. Okay, and then in the interest of time, I could say, okay, great. I know each one has an area, each full box has an area of 4 meters. 4 times 13 gives us 52 meters, plus the 9 partials. So I know it's got to be over 52. So it can't be any of those. So it's got to be 74. That's how I figured it out. You can get the exact number. If this wasn't a multiple choice question, I would have to. But it is a multiple choice question, so don't waste your time on that. Last one. 2 cars, P and Q. P's the red, Q's the black. They each start from rest, which is key, at the origin and move along the x-axis. This is an acceleration time graph, and what identifies the speed, VP and VQ, of the cars at time t. So to get that, we find area under the curve. The area of a triangle is 1/2 base times height. Okay, and again, acceleration time gives us meters per second squared times seconds, which gives us meters per second. So that's velocity. So we're like, okay, got it. We're doing the right thing. So here's the deal, right? For the black car, the base is t, and the height is 10. For the red car, the base is t, and the height is 10. So these are going to have the same speed because you're just doing 1/2 times 10 times t each time. Done.